Naidu, Muhammad Najib, Sanggawi, Ariful Islam, Muhammad Kazim, Teresa. Please enable your webcam. We wait until another 1 minute, 11:35.
Excuse me.
Yes.
Yes, I can turn off on the camera because I have a problem in my laptop.
Okay. Sanggawi, Muhammad Kazim, please enable your cam. So now I'm going to switch to what SCSR 2033. I guess there is 2 students need this QR code. Okay, so I'm going to start continue our lesson. Where is it? Okay, I'm going to share my screen, but before that, we are until instructions, isn't it? Directive identifier. Okay, it's okay. I'm going to do some recap also. Still, who's not turning on the webcam? Ariful Islam and Abdul Kasim. So I'm going to pick your name later on.
No, I will open it now, Doctor. Just 1 minute.
Yeah,
Okay.
doctor, I'm just switching to mobile. So then I'll say webcam soon.
Muiz. Okay, let me do some recap what we have learned in our module 3. But before that, what is the problem? Who still got the problem with your lab? Who still got a problem with wait, I need to mute him.
Yes.
Who still have okay, what happened? Who still got problem with your lab 1? No problem. But I see a lot of you asking. Yeah. Let's
Yes, I
check
have
out.
problems.
Okay, what happened?
Maybe the version of my Visual Studio not I can't use can't work good. I think I need to change my application. But here I
Maybe you can just reinstall it.
yes I have yes. Excuse me.
Maybe you can just reinstall it. I think reinstallations is not taking too long. Instead of you just waiting for the error, maybe you can just reinstall, and please make sure when you reinstall all the software are running and installing in C. So others? Siapa ni? Abdul Aziz. You're having also problem. No watch. This one we already discussing. When you need to have window, watch, auto, and memory. Same goes to our last previous class that you need to do the step over first, which is F10. But it's okay if let's say there is no more question. I'm going to proceed with our module 3. We did also look into several, which is our basic elements of assembly language. We already look into the real number constant, integer constant. You already know also what is the difference between integer constant and also your and also your real number constant. So the uh I why I cannot draw? I think I using pen. Highlighter can pen. Okay, now okay. Okay, we already look in. This is the one that represent a real number constant, and another one is integer constant. There is huge differentiation, especially on your radix. When you have your radix, means that it is integer constant, while mostly others, like more on numbering, is a real number constant. Wait, I need to accept. Someone wanted to join. Oh, okay. You also already look into char, string, and string. You know that what is the difference between character and also string. So character normally one letter only, one single. It is a from ASCII character, and for string, it's going to be like words occupy several occupy several character inside. So you already also look into reserve word. So some reserve word that you already look into the instruction numerics, directive, type attributes, operations, operator, and predictive symbols. So today we're going to look into what is basically instruction numeric, directive, attributes, operator, and predictive symbols. We just until here last week. So we are under until identifier, isn't it? Correct, right? Who just want to join our class? I need to go out. Circle. Okay. Sometime due to my age, I forgot where is our last previous class. So I guess it's until identifier. So under identifier, you need to have identifier. You need to identify something. The one that you choose. You can have any name, only that you cannot use the reserve word. So there is 1, 2, 3, 4, 5 reserve word that you need to avoid uh not to use in your identifier, because identifier normally that you are the one that said. It might identify a variable, a constant, a process, or a code level. You can identify any of your variables, the set of your variable. Maybe you want to uh identify. I give only a example. I want to identify my number. This is my number, and I identify it as uh my number, let's say. So this is your identifier. You can use any name, my number, or maybe you can also type my number. So this is identify that my number is 197. Mm. So this is the example of how you're going to identify something. So it may contain of 1 until 247 characters, including digits. Including digits means that okay, I have the set number of 190. So let's say this is only two different number. So maybe there is a set of it, but it's okay. I just want to share the very simple example. So one number I represent is as my number one, or maybe another one is my number two. So whenever I call my identifier, which is my number two, I know the value is 190. So I identify another number which is 197. So it is my number one as the identifier. So this is just a simple example, which is what you can use in your identifier. And it is not case sensitive by default. So otherwise, this one I already teach in our previous class, but I just do some recap on it. And first character must be a letter. Uh, so this is the example letter that you can use. And in subsequent character must be also digit. So first must be a character, and in between maybe you can have my two number. So in between you can also have as a digit. Identifier cannot be the same as exemplar reverse word. This one we already looked into. So next is under the symbol. The symbol is used to extensively by the assembler as a prefix for predefined symbol. So avoid using as identifier. You need to avoid it to be used in identifier. Make identifier name descriptive and easy to understand. So as long as you can understand it, so it's okay. Example of some valid identifier. So this is all the valid identifier that you can use. And for information also, we already looked into this identifier last class. So for your informations more, you can proceed to pages 62 for books under Pearl Education Limited. So next is on directive. So a directive is a command embedded in your source code that is recognized and act upon by the assembler. Apa maksud dia tu? Not execute at runtime, can define variables, macros, and procedures. Not case sensitive, same goes to your directive, and it recognize like dot data, and dot data is equivalent. Sama je. Kalau you ada your directive punya tu huruf besar, huruf kecil, which is capital letter or small letter, it is basically same. Dot doc similar. It's too ugly. DOC. It's similar to .D or C because it is not case sensitive. So different assembler have different directive. Of course, you're going to have different directive for each of your assembler that you have. So example to show you the difference between directive and also instruction. So this is your directive and the instruction, you're going to see what is the instruction after this. This is the instructions. So first of all, tell the assembler to reserve space in the program for a double word variables. So you can see over here, DWORD mean double words. So after this, you're going to see, where is the double word? Is it here? Okay. So you can see what is the bit. Kenapa dia tiba-tiba tertarik? Okay. Byte is 8 bits. S byte is S bit, but it is S stand for sign, B stand for byte. Word, S word, and this one, your double word. So your double word is 32 bit. So you want to assign 32 bit. Later on we're going to go back to this table. So I just want to show you this is the word. So you're going to remember all of this. 32 by unsigned integer. It is unsigned integer. Can also be a near pointer to the protect mode. D stand for double. So go back to our previous slide. Okay. My var. So this one, you the one that you put, which is your my var, which is my variables maybe. So the word you want to assign double word. So berapa tadi? 32 bit, right? So 32 bits you're going to reserve for the space for your assembler. So this is the word directive. So apa 26 ni later on you're going to learn one by one. So this is just example how you going to write your directive. This is directive. And under instruction, you can, after you have assigned anything like maybe I assign my number is word. Words saya tak ingat apa. Maybe it is 32 byte also. And then I put somewhere like 17. So this one is I think in decimal. So you need to convert to hexadecimal letter or what is this? So all the 32 byte you're going to put 17. How you going to put? Later on you're going to learn. After you already give the directive to your myvar, then you give the instructions. Move, M-O-V. So you move EAX. Apa yang ini ni? What is EAX? You already look into your Visual Studio. You have found EAX, EBX. Apa lagi? EDX. So there is a lot. So basically, this is all your register. After this, there is a slide on this one under register. So EAX is register. So E normally it is extend. A is I forgot what's the as accumulator. Accumulator. And then this is a register. So AX is accumulator, extended accumulator register. Kalau for B, uh, extended base register. Kalau C, extended counter register. Kalau EDX, D4 data, extended data register, and blah blah blah. After this, we go into look into all of the register. Saya batuk so saya nak kena betulkan tekak saya ni. So saya akan I'm going to cough a lot. So MOV, this one is your instruction. You give instruction MOV. What is MOV? You move execute a runtime copying the content of your myvar. This one is your myvar. You copy it and you put into your register EAX. So this is how you write directive and instruction. So this one is just a basic for you to learn one by one. So now it is instruction. I guess suppose this slide is before this example, so then you can see directive and also instruction. So this instruction is an execute statement when a program is assembled. So instructions are translated by assembler into machine language, which is Python, which are loaded and executed by CPU at running time. So bacalah sendiri until you faham. But basically, if you look into the example, then you can see, okay, of course, this is directive, which is you want to assign your your myvar to something like the space, whether it is byte, how long you want to use for your myvar, and then after that, for all the informations in your myvar, you're going to move this one your instruction. Maybe you can also like add add one myvar. So maybe you're going to add one my into one. So I just give you example. Maybe this one is ABX. Maybe you add this myvar with ABX inside already. Any information that will be inside ABX will be add with your myvar. So you have myvar and you add with ABX, something like that. So that is example on instruction. So you have 4 basic part in your instructions. First, your level, which is optional. You can have the level, you cannot have the level also you can. So either one, you can have the level, sometimes you cannot just ignore it. And the one that required is instruction, mnemonic. The one that after this you're going to learn. I think suppose it's going to be earlier the slide, but it's okay. Later on you're going to learn on instruction mnemonic. What is the instruction mnemonic inside here? So this is your instruction mnemonics. The one that require, and your instruction your instruction over here, you have 2 instruction and also operands usually required also. Your operand mana? After this you're going to look, and lastly a comment, which is optional. You can put the comment. This is the comment after this, just to maybe you have too long programming. you want to remember it later on, it's very hard. Or maybe you write the programming for someone else. So that's why you put a command. After this, you're going to learn also command. There is several way to write, not only just this way. Okay. Mana pen saya? So this is under label. So a label, this one is not required, right? It is optional, whether you can have it or whether you cannot. A label is an identifier that acts as a place marker. So this is the keyword for instruction and data. So follow identifier rules. It follow the identifier rule. You can have two type of label. You can have data label and you can also have code level. For data level, you need to identify the locations of variable. For code level, use a targets of jumping and looping instructions that end with the colons character. So this one is the target, which is code level. You have a target and looping instruction. While for data level, you just have the location of variable. Satu je. Like this one, this is the target. Move somewhere. So all of this is your code level. But for data level, you have only one. Something like this, which is count this with this. How many times do you count? Define a variable name count. And for the code level, example is jump instruction. Transfer control to the level target and create a loop. So you have a loop over here. All inside over here is your code levels. You're going to do this move. You're going to do any kind of instruction inside. And this is jump target, which is you're going to jump to this target again. Repeat, something like that. Creating the looping. So this is the one that I mentioned. You need to have the instruction mnemonic. This one is required. So you are required to have the instruction numeric. Hmm? I hear the. Okay, Irfan.
Doktor,
Ya.
ada kawan saya nak masuk, doktor. Ada tak?
Tak ada pun.
Sekejap,
Nampak
saya
tak?
tahu.
Cuba dia macam ni unrequest. Request balik sekali.
Saya dah beritahu dia. Dia kata dia dah masuk dah, doktor.
Okay. Okay, so you have the instruction mnemonic. There is several. Banyak sangat you boleh ada, which is a short words to identify the operation carried. So you need to remember all. So kalau MOV ni, what is the meaning of MOV? This one is just example. You can have a lot of others under assembly language. Add, subtraction, multiplication, jump, and then call back your process and so on. So this is example under instruction mnemonic. And the one is required. And operands. Assembly language instruction can have between 0 and 3 operands depending on type of the instruction. So you boleh ada sampai 3. That's why sometime after this you going to see I give you example. Mana example dia? Okay. Example 3.1. So you can see you have 2 operand. You boleh ada lagi satu lagi dekat sini. Maybe you just taruh 1H. Just give example. This one is 1H maybe. So you have 3 operands. See? So back to our main slide. Mana dia pergi? Okay, and the operand. So you can have between 0 and 3 operand. So you boleh ada 3. And the minimum is 1. So this one is, you can see 1, 2, 3. You have 3 operands. So this is the example. And operand types is constant immediate value. So you can see your constant. Ni you dah belajar kan, whether it is constant or whatever operand types. And over here you can see this is the constant expression, but this is 1 only. And you have over here, why you have register? Okay, for register you can have EAX, EBX, AA, AX, AH. So you need to have 3 only, the maximum. So between 0 to 3. And memory, you can have operand as a count. So if you look back in your instruction over here, so you have the instructions of this one is your what is it? Your mnemonic instruction mnemonic is the move. And another one, what you need to have is your operand. So your operand will be your myvar and EAX. This one is register. Myvar, this one, I think depend on what is the value of your myvar, whether it is a constant or whatever. So that's why if you see under instruction, you must have instruction numeric and operand, at least these 2. So this is your mnemonic instructions, and this is your operand. You have 2 operand over here. So it is under instruction. Now go back to over here. This is the example assembly language instruction. Sama je dengan atas. Okay, having varying number of operands. So ni nak tunjukkan different number of operand. So over here you can have 0. Maksudnya if you have 0 operand, also you can have STC. This one is your mnemonics. Then you go back to here. And then, okay. Instruction numeric required. Ni mestilah. This is must. For your instruction. But for your operands, it's also required. But it is usually. And your operand is from 0 to 3. Yang the rest is optional. Label and comment is optional. And go back to the example. You can see over here, this is your instruction mnemonic. And you have 0 operands, which is no operand. This is comment. which is optional. You can have this, you can also just ignore it. Optional, which is set carry flag. This is the instruction for you to set carry flag. And then INC EAX. Okay, INC EAX, you can see you have the instruction mnemonics and also which is increase, I guess, INC. And you can see that this is your register, one operand. You have one operand and you need to add one, which is because you can see increase. Increase 1 to EAX. What EAX I already mentioned, it is extended. E for accumulator. X of course is referred to your register. Accumulator, this one is base. But both is register. But register, there is a lot of different type of register. So this one, another example of instruction, move. So this one is your instruction mnemonic, and this one is your operand. So you have two operand, which is destination and also source. Dia terbalik betul lah. Destination and source. Dia terbalik. You kena from this you masuk sini. Dia bukan daripada count pergi sini. Count pergi ke EBX. No. You going to point your destination first. Then you will say, okay, this one will be go to the destination. So this is how you write the instruction in your assembly language. You point something which is move. This one is destination. This one is the source. EBX to the count. So B, this one is extension base register. You have two operands and you need to move EBX to your count. So I guess this is the example and easy for you to understand on the assembly language instruction. And then comment. Comment, this is not very important, but it's important for those who want to learn. And also for the programmer to know back. Sometimes you already forgot what is the program code. Sometimes this new coding that you learn, then of course you need to put something, a mark. So it's called as a comment. Then you can refer it back, or maybe you write the programming and you want to tell others about the programming, to learn the programming. So easy for you to put the comment because it's not going to be effect when you run your coding. So it's not going to affect anything when you put as a comment. So comment are important way to writer of a program to tell or describe a program design to the person reading the source code. Typically comment, you have the description, you have a name of person who create or revise the program. Of course, maybe you want to tell someone, okay, I'm the one who write the comment, and also maybe I put the date 14 April. So then I know I made some changes here at this date. So later on I can revise it. So program creation and revision date. Okay, this one, see? Then if you want to change, later on you will change the date and so on. So technical notes about the program implementation also. So any kind of sentences or word that you want to put just for you to know more about the coding. So it's on the comment. So comment, there is two ways to write it. So that's why I mentioned for you earlier in our early class. A comment also you have several way. So normally if you look, you can see this type, which is began with semicolon. So you can see, okay, this all the comment. Similar also, and all the instruction. This one is the comment. So this is the comment. So you can see that this is single line versions of comment. But if let's say you have too long of comment, or maybe description about your programming, description about yourself and so on, you can have a block or multiple line comment. You need to start with comment, and then you put these marks and end with this mark also. So inside all of this is your comment. Maybe you can put like comment, and then the programming is for something something. Let me check. Okay, let's say this one. You have this comment. Uh, how to zoom? I forgot. How to zoom to make it bigger.
Control and then scroll.
Control?
Control and then use your scroll wheel. Is it working? Or there you go.
Okay. Thank you. So over here you can see that you have, this is one command. So maybe you want to have long. Maybe I put over here command, and I put, this is my coding. My, maybe you have a programming test. You're going to put your name, your information, uh year one, let's say class SEC, something something, and you end up with this. So inside this also, this is the command. So you can also write in this type of command also. Like this one, this is the command for these sentences. Come back to our slide. So now you know that there is two type, how there is two way how you going to write your comment, with a single line or block or multiple line. So maybe you can have a try the review question by yourself. There is several question. And now we're going to our register, the one that you already look into in your um okay, when you try your lab, you already look into all the output. So your output, you can see that normally you can have EAX. You can have also the EBX. You have ECX, EDX. As I already mentioned, EAX. A means the accumulator. B is base. C is the register for your count register. D is for your data register. Later on, you will see also you have S, I, DI. Later on, you will learn it. And this one, carry flag, sign flag, and so on. So now we just want to look into our register. So over here, you can see that register a high-speed storage location directly inside the CPU, designed to be accessed at much higher speed than conventional memory. So if you have a register, this is a more high speed storage rather than your current and normal memory. And the general purpose of register are primarily used for arithmetic and data movement. So for your arithmetic, what is arithmetic? Your program for uh, addition, subtraction, multiplication, apa lagi, division. So that is under arithmetic. Kalau tak tahu lagi arithmetic tu apa, you going to go copy this arithmetic and paste it on your Google. So there is a explanation on it. And data movement, that's why you can see move this to this, move this to that. So over here, what is AH? So AH is your high accumulator register. This one is accumulator register, but this one is referred to high. This one is referred to low. And you have this one is byte, which is 8 bit plus 8 bit. And then for word you have 16, and for D word you have 32 bits. So you will notice that how many that you are required for certain process that you want. For arithmetic, whether it is a logical or other operand also. Your 32 bytes, 32 bits is including EAX, EBX, ECX. Wait.
Miss,
Yes.
what is AX?
E
AX.
AX actuator register. Accumulator, sorry. Accumulator register.
Oh, okay.
Mana saya nak tulis ni? So ku kenapa saya punya mouse ni? A A stand for accumulator. So this one is accumulator register. This one accumulator high. This is low. This one is E for extended. Then you have B for best. Lagi you ada apa? You have C for count. You're going to have also DX, EDX. Then this one is data. So no.
Miss, we need
Apa? Yeah. Like,
a proper note of all the names.
I don't know why previous slide. This one is our previous slide. So our lecturer refer to this. There is no explanation. So it's direct jump to AHAL. Whether you already learn on register or not, right? Something like that. So I think if let's say I'm new student, I don't know what is this. So it's hard for me to understand, especially when we are playing around with our Visual Basic, isn't it? And it's
Can we
also
just Google it?
what again?
Can it is in Google if we look it up?
You can Google, but I think some of that is full with information, some is not. I also already tried Google it.
Understood.
And You can do some revision also through here. Pearl Edition Limited, I already put in our e-learning, right, in the resources folder, in your e-learning. So please try to check it. Maybe there is more instructions on that. And I will try to make extra notes. Yes. I will try to make extra note on the register. What is the meaning? Because I also weird why we need to do the lab one first, and when we get the answer, I don't know what is the point. What is this all? Something like that. If I just knew with the Visual Studio, I totally clueless. So
But it's random coding.
yes, but I guess basically the lab should be after we cover module 4, because oh lama saya tutup pula. Because I think after we have the strong basic, then when we run everything like this, then we know, okay, oh, this one we already learned, or this EAX what, CF upper, SF upper, this one is carry flag. But now we also didn't understand what is PF, what is basically our coding do. Mm. So that's why. But it's okay. I try to make extra note just for the basic things. Then you can have a strong understanding later on.
Thank you.
Mm, because you need to have the table also, I guess, for the bid word, the word, and after that S word and so on. So this one, there is already point. These tables already point every register. So under 32 bits, you are having EAX, EBX, ECX, EDX register. For 16 bits, you have AX, BX, CX, DX. You can see why E is called as extended. It is extended from 16 bit. Itulah dia punya coloration. So you have AX, and then for 8 bit you have AH, BH, base high, count high, data high, accumulator, is it? Accumulator high, and low. L over here, accumulator low, base low, count low, data low. This one is just a register. So, this is what the table. Then you need to know and remember for 16 bit under which register. For 8 bit, what is available. But for 8 bit, it will be divided into two, which is high and low. So you have two for 8 bit. So I will add extra information, extra note, especially in the register. Then you can have a strong understanding in it. So we're going to jump to our adding and subtracting, as we notice that all of these are for our arithmetic. So adding and subtracting is under arithmetic process. So we will see that previously we have the program template. So the template is .asm. Over here you can see, over here you have main.asm. This is the template that you are using normally for running the assembly language. And When begin a new program, it helps to start with empty shell program with all basic element in place. So why you need to have the program template? Because when you have template, you can just uh, start with that and you just put what you want to add. So later on, you will see what is the template. So redundant typing can be avoided by filing in a missing part and save the file under new name. Okay, so this is the template. This one is the basic only. When you run, there is nothing up, of course, but this one is the basic template that you need to have. You need to have the library, include include irvins32.inc. This is the library that you pointing in. That's why you need this library to be in your local this C. You're going to call out your library, and after that you have dot data. You can have your instruction, your variables here after dot data. So this is the template. So when you have template, easy for you to write anything. Okay, this part is where you going to put your variable. After you have dot data, any data that you have, you will have dot code, which is the main process. So you're going to insert executables instruction here. So your instruction will be somewhere here. This one is your variables, your data. And after that, you have your main and process, which is you insert additions. Let's say you have any addition process. After your first process finish, this one is your main. Then maybe you're going to have your extra process. Then after this finish, then you're going to run this one. So this is the end main. So you can see this is main and P, which is only this finish. But end main means that all the process is already ended and finished. Okay, is it okay? So this is just template. That's why you just require to use this template. Later on, you will add inside whatever coding that you want to assign. Same goes to our template. You can see you have include. You have dot C. Basically, you can also have dot BA dot data. It is similar whether it is BA and BA. As mentioned, it is not a what it's don't care whether it is cap lock or capital locks or lower case. And you can write your programming here, somewhere here. So this one is just a template. It's given already. So then you can copy paste. There is a part for you to copy paste this one. Later on, you can just use it. But in your lab one, it's not given there because it's already give you direct to your code, which is what you need to do. Now you can see what is basically the instruction. Before this, maybe you don't know and you clueless what is happening. Now you know that you move this 10,000 it is in hexadecimal, 10,000 hexadecimal in your EAX register. Then after that you add 40,000 to your EAX register. Now your register already be 5,000. Then you can know. Then you subtract and you get the wait. Alhamdulillah. Alhamdulillah. So this is what is happening. So I guess lab 1 should be after we finish all this module 3, but yeah, I don't know why we start it before. I just follow others lecturer also. So the objective is for you, and also you will notice in your lab 1, it just require you to review and then uh, debug. So it's just for you to learn how you're going to use your Visual Basic. So go back to our slide. You can see over here, this your tables template .esm, and there is example when you need to adding and subtracting. So your register are used to hold the intermediate data, and we call a library subroutine to display the content of register on the screen. Next is the process code, source code. Let's go through the programs. Okay, over here. This is your nearly similar, but I guess over here is different. Oh, same. So you can see this is the one that you put in your program. So over here you can see that you move this to your register EAX. So now you know that you have 32 bits integer, and you have 40,000, and you add to your EAX and you subtract with 20,000. So your final answer will be 530,000 hexadecimal. And you're going to display the register, which is called dump register as it. So this is what happened. There is an instruction which is you move MOV, which is move, which is you copy the integer 10,000 to the EAX register, and then you're going to add 40,000 to your EXX, and after that you subtract. So your EAX will be 32,000 hexadecimal. So because it is 32 bits, so you're going to see that 1, 2, 3, 4. So all of this, you please check back. I guess you already learned in your digital logic also. This refer to how many byte. This refer to how many bits and so on. So you can see you have 32 bits. Later on, I will give you, I think, extra note for you to see clearly how the header supposedly look like. If you have 32 bit, why you need to have 00 in front? And the following is snapshots of the output. Okay, you can see this is your EAX. The rest is basically maybe by default is already in your register because you are not doing anything on it. So the one that you are doing is currently in under EAX. Then you have program 3.2. I guess, is it similar? Okay. You have similar, which is the one over here. Why it's program? Okay, this one is similar. So I guess I need to stop until here first. Because if I jump to this part, before you have strong understanding, you're going to clueless. I think especially in your exercise 3.1, you have these two operands. Then you need to have the answer also like this. What is your offset? Only the example is quite simple. You have this kind of double word. You will take this first 7, 8, 56, 34, 12. It will follow the sequence, which is you going to store the LBS first and follow by until your MSP like this. But when you have two operand, what is going to be happen? Whether this one will be here or whether this one will be here. So please later on try to read first because I already give you all this note, and try to think what's supposedly in offset 000, what is supposed to be in offset 006, and etc. So that's why I guess we need to stop until here first. And tomorrow I hope we're going to finish all. And if we cannot manage to finish, we're going to have extra videos only. Then you're going to refer to the video. I will put also and upload extra notes in your e-learning. Okay. So any other question? For those who still did not scan your QR code, you can scan now. And for those already scanned your QR code, you can leave this Google Meet. Okay, thank you class for your participation and have a good day. Bye-bye.
Thank you, Doctor.
Okay, thank you.
Doctor,
Thank you, Doctor.
Thank you.
Doctor,
Yeah,
may I ask some question
yeah.
about the face-to-face class? When is going to start?
I guess we already come out with the percentage. Most of you, 63.4 will be coming back to UTM, and 63.6 not going to come back. We going to see what is the academic office will inform. Basically, we're going to do after Raya. We're going to do after Raya, but it is only lab class, not the lecture class.
Oh,
Lab class only. So I think all our lecturer also don't want to take any what any
Risk.
any risk. So they also want to try to finish all the lab before Raya. But we need to also follow the rules. Will be coming out from academic office. So we cannot decide yet.
okay.
But you need to submit right the letter if you want to come back.
Yeah.
Yeah.
Baliklah, baliklah. You first time right datang sini kan?
No.
Isn't
Yeah.
it? So you first after this maybe I will upload video. Saya buat video ni. I buat tour dekat UTM ni. You boleh tengok lah college-college mana. Nanti you nak pergi kompleks sukan kat mana semua. You main gate kat mana. So we
Ni
share.
buat video panjang sikit pasal meranti.
Meranti. Meranti buat apa? Saya tunjuk je meranti kat mana tempat you nak
Ya,
makan. But I don't know lah whether this bulan puasa buka ke meranti. Tak tahulah. Siap.
Masih buka rasa sebab masa foundation kita orang masuk time bulan puasa.
Okay,
Jadi
dia buka waktu bulan berbuka Nanti
tak.
ah.
Boleh je macam pukul 4 nak pergi beli makanan buka puasa lepas kelas.
Oh, dah ada So
Yeah.
hari ni saya nak pergilah. Mesti ramai orang
Yang ada. Tak sure lah. Tengok lah. Kalau ada yang tak puasa, okay.
Because bazaar, if you go back to your 5 year back then, I think 5 or 10 years before this, we have bazaar at UTM. Dalam UTM tu depan in front Meranti.
The gate. Bukan the gate je.
In front Meranti tu ada college KTF KTDI. So dekat situ area tu depan FABU, Faculty of Awam, there is Bazaar Ramadan.
Dekat parking lot tu ke? Depan nasi bajet
Betul.
depan KRP, yes.
Dulu ramai, tapi sekarang ni saya tak tahulah sebab semalam saya tak masuk, semalam cuti kan. Saya tak rasa ada sebab tak ramai pun student dekat sini kan.
Pasar Selasa ada tak, Miss?
Apa dia?
Pasar Selasa.
Pasar Selasa. Kat mana tu?
Dekat kita orang every Selasa kalau nak sikit. Bukan, Miss. Ada satu pasar dekat
Depan Tasik Ilmu.
apa dia?
Tapi if you look kan you ada Meranti. Satu lagi you ada apa? Cengal.
Yes.
Cengal pun tutup tau. It's closed. Ada satu je kedai. One shop je yang buka. So kalau you all balik sini, I tak tahulah diorang buka ke tak. And then last time College 9 pun satu tumpuan lah. Maksudnya College 9 kita selalu pergi beli makanan kat situ, lepak-lepak kat situ. Tapi sekarang ni tutup semua.
K9 K10
K9 kan College 9 yang ada tu. Ada dia punya apa? Cafe. K10 tu college dia. So semua dah tutup. Saya tak tahulah kalau you all balik sini nanti lepas raya, diorang dah terus buka ke tak. So kena standby lah nak beli makanan macam mana. Takkan Fu Panda je tiap-tiap hari.
Saya harap makcik Meranti tu ada lagi.
Meranti buka. Semua buka. Meranti is okay. Tapi
rindu saya dengan makcik tu.
How come you nak support semua kan? Maksudnya banyak college. Kan kita banyak college kan kat UTM ni. Takkan semua nak tertumpu kat Meranti.
Ya tu, kita orang pun maut juga masa ke foundation. Kalau semua tertumpu kat sini, memang tak tahu lah.
Jenuh lah sebab ramai orang nanti nak berebut pula. So good luck. Baliklah UTM ni cepat. Sebab saya pun tak suka keadaan sunyi macam ni.
Apa nanti saya support, Miss.
Alhamdulillah. Saya banyak kali ni saya tak makan ni, saya puasa. Okay. Thank you. I need to go now. Meet you again tomorrow. Bye-bye.
Alright,
Bye,
Miss.
Doktor.
Thank you.
Okay, bye.
Doktor.
Doktor, saya ada
Yes.
soalan.
Okay, ya.
Macam
Sorang.
Hi,
Yang
Doktor.
reserve words tu.
Apa? Okay.
Reserve words.
Recious word.
Reserve.
Reserve.
Reserve words.
Okay. R word. D word semua tu ya? Double word semua tu?
Yang move, add,
Ya.
include. Tu semua wajib huruf besar.
Tak adalah. INT tu kan huruf kecil. Ke yang mana satu ni?
Yang macam include.
I include tu. Yang include tu ya? Include library semua tu ya? Include library tu dia memang include tu huruf besar. Tapi I rasa you boleh huruf kecil juga. Dia tak ada kisah huruf besar huruf kecil. Kan macam tadi tu. Mana dia kata dia tak kisah. Mana saya punya. Okay, your include tu you boleh huruf kecil huruf besar. Kalau yang dot data ke dot doc data dot code semua tu you boleh huruf besar huruf kecil. And pun suppose kalau you tengok and dalam C programming ke, diorang huruf kecil je. Ant-Man semua. Tak apa, nanti kita tengok satu-satu lagi. Kita tak sampai situ lagi. Sebab saya rasa tak strong pun lagi. Dia punya lontar pun tak berapa lengkap. Macam tiba-tiba dah jump pergi ke sini. Tiba-tiba dah jump pergi ke sana. Macam tu lah.
Lepas tu kalau yang identifiers,
Okay.
katanya kena mula dengan letter kan?
Letter tu ABC ataupun you punya apa ni, simbol.
Underscore pun boleh. Letter
Dia
atau simbol.
dia bukan digit. Bukan digit.
Oh, okay.
Hmm.
Itu je. Terima kasih doktor.
Okay. Tapi digit. Okay.
Hi, Doctor.
Hi.
Yeah. I want to tell you I have problem for
Visual
program.
Studio.
Yeah, Visual Studio. I download it, and when I do the lab, something wrong. Said the computer not access with this visual. I don't know because I just take a new laptop, but I don't what's happened for this program.
Can you just reinstall it first and then you reinstall?
Yeah, I will do that.
Because I guess maybe, but please make sure you just forward, which is it will follow the recommendations, which is C disk, local disk.
Yeah, but in another laptop, my
Yes.
friend have laptop. I do that. It's already okay. But in my laptop, I don't know what's the problem. Maybe I will take it and go to do update for Windows or for my laptop.
Okay, but if let's say you still have problem after you reinstall, please inform me. Maybe we can personally do a G-Meet session. You will share your screen and I will check what happened.
Okay, I will do that. Yeah.
Okay.
Okay. Thank you, doctor.
Okay.
See you.
Okay, bye.
Bye.